Hello students, today in this video we discuss about geometry of a molecule. Different molecules are made up of atoms and these atoms are oriented at a different position which determine the shape of a molecule, geometry of a molecule. Actual geometry of molecule or orientation of a molecule, bond length that can be identified by analyzed by X-ray diffraction, electron diffraction, and here we discuss about some theory which help to determine shape and geometry of a molecule. At first, what is the geometry of a molecule that we discuss? Geometry of molecule. Geometry of a molecule depends upon arrangement of atoms and bond angle. Geometry and shape of molecule depends upon arrangement of atoms and bond angle. Actual geometry and shape can be identified or find out by X-ray diffraction or electron diffraction. Method, and theoretically it can be calculated by various theory, and here we write various theories are used to predict theory of or geometry of molecule. And here we discuss about most important theory, VSEPR theory, and it is also known as valence shell electron pair repulsion theory. This theory explains geometry of a molecule on the basis of electron pairs found around the central atom in different covalent molecule or compound, and here we write the theory which explains geometry or shape of covalent molecular compound on the basis of repulsion among electron pairs found around the central atom is called VSEPR theory. In this theory were given by Gillespie, and according to him, central atom surrounded by electron pairs, or that remains surrounded by atoms present in a molecule, and therefore there is crowd of electron pairs around the central atom, and due to this reason there exists repulsion among the electron pairs like lone pairs and bond pairs, which determine the shape of a molecule. And this theory is based on given postulates or assumptions. At first, central atom of covalent molecule surrounded by atoms. Second, as is here, there exist electron pairs around the central atom. Central atom remains surrounded by electron pairs. Mainly two types of electron pairs are found, and we define electron pairs are of two types which are present around the central atom. These are the pair of electron involved in bonding are called bond pair, and remains without bonding are called lone pair. In this way, central atom remains surrounded by two types of electron pairs called bond pair and lone pair, and there exists repulsion among the electron pairs. And here we write third assumption is there exists repulsion among electron pairs. And that repulsion is in order. Repulsion among the electron pairs are greatest repulsion found between the lone pair. Here bond pair we can denote it by BP, lone pair by LP. Then highest repulsion, maximum repulsion found in lone pair. If lone pair, two lone pairs are found, then maximum repulsion occurs and bond pair pushed downward. And then lone pair, bond pair, and minimum repulsion found among the bond pair and bond pairs. And that existence of lone pair, bond pair help to determine the shape of molecule. And here fourth assumption is here number of electron pairs give the idea of shape of a molecule or geometry of a molecule. and electron pairs and shape here we write, or geometry also we call it. If a molecule contains different number of electron pairs, then different type of shape present. If 2 electron pair are present, then it gives linear shape. 3 electron pairs are found, then planar trigonal. 4 electron pairs are present, it gives tetrahedral. Listen, tetrahedral shape is present when 5 electron pairs are present, then trigonal pyramidal. Pyramidal shape is found, and also we write bipyramidal. 6 is found, then octahedral. When that number of electron pairs help to determine the shape of molecule, and we can predict the shape of molecule on the basis of electron pair. If electron pair is only 2, then linear, 3 then planar trigonal, triangular also we can write, 4 then tetrahedral, 5 electron pairs are there, then trigonal, bipyramidal, 6 then octahedral. After that, the presence of lone pair push the bond and shape get changed, or that is distorted or disturbed. Yes, and that number of a lone pair actually determine the shape of a molecule. Yeah. That is, it causes bond pair or bond angle decreases. Yeah. Bond angle get decreases. That help to find out exact shape of molecule and how much there is presence of lone pairs, then a greater push on bond occurs. And this theory help to explain about if there is no any lone pair, then shape is like that. If number of lone pair increases, then it causes more disturbance produced and different molecule having different shape. And here we discuss about common geometry of a molecule of some compound according to VSEPR theory. As for example, first is here beryllium fluoride. Beryllium fluoride contains central atom beryllium, and here we found in beryllium 2 electrons are present, fluoride 7 electrons are present. Listen, that represent that fluoride electron, here beryllium electron, here beryllium valence electron, Again, fluoride. Two, 4, 6, 1, 7. In this way, we found that the central atom is here beryllium, which contains only two bond pair, having no any lone pair. That is, two electron pairs are found around the beryllium atom, and having these two are bond pair. And here we write, in beryllium fluoride, the central atom is beryllium. It contains two electron pairs. Both electron pair are, or pairs are, bond pairs. Having no any lone pairs. Due to absence of lone pairs, that number of electrons help to suggest its geometry, that is beryllium, fluoride, and here it has linear shape. Due to absence of lone pair, the bond angle is here one between BF, F bond, FB, F bond is 180 degrees. Linear structure is found in beryllium fluoride. Why it is so? Because only bond pair is present, absence of lone pair, it has linear structure. Similarly, we describe next molecule, boron fluoride or trifluoride. BF3. In boron trifluoride, we found that the central atom is boron, and around the central atom, boron, three fluoride is found: fluorine, fluorine, and fluorine. Pair of electrons. That boron having 3 valence electron. Fluoride share 1 electron pairs. Fluoride, and it has 7 electrons. 2, 4, 6. That 6, 1, 7 represent fluoride electron. 6, 7 electron represent fluoride. Seven electron represent fluoride, and that these 3 are electron of boron. And we found that how many pair of electrons are there? 1, 2, 3. And here we write, in boron trifluoride or fluoride, the central atom is boron, which has 3 pairs of electron pair around it. Listen, boron is confined by 3 pairs of electron. The 3 pair of electrons are only bond pair. Having no any lone pairs. Yeah. No any lone pairs are present in here. All electron pairs are involved in bonding, therefore bond pairs are present there, giving planar, trigonal or triangular structure. And we can draw a structure like a boron, fluorine, fluorine, fluoride, 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 fluoride. And here it gives geometry like trigonal in shape, in which each angle is about 120 degree. It is called planar trigonal. Listen. And in this way, VSEPR theory helped to explain the structure of boron trifluoride. In that only 3 pair of electron pairs are there. 3 pair of electron pairs, then already we discussed that here having planar trigonal structure. Similarly, VSEPR theory explained the structure of methane. In methane, we found that the central atom is carbon and surrounded by 4 hydrogen atoms. And here we draw the structure of methane like that. It contains 4 pairs of electron, 4 pair of electron pairs bonded with hydrogen atom. See here. That colored part denoted that electrons of hydrogen, and here 1, 2, 3, 4 pairs of electrons are found. And here we write in methane, central atom is carbon. Carbon, listen here. The central atom is carbon, bonded or surrounded by 4 pairs of 4 electron pairs. Electron pairs having no any lone pair, only bond pairs are present around the carbon. All the electron pairs are bond pairs having no any electron pairs. Hence, the geometry is, according to VSEPR theory, we found that if 4 electron pairs are there, then geometry will is tetrahedral, giving the angle 109.5 degree. Yes, and we draw a structure like carbon that remains bonded with 4 hydrogen tetrahedrally. Carbon, hydrogen, hydrogen, hydrogen. And we can show the shape tetrahedral as if that hydrogen goes in opposite side that, and each angle will be here 109.5 degree or 280 degree. And in this way, VSEPR theory explains the geometry or shape of methane. After that, we discuss about next molecule on the basis of VSEPR theory for water molecule H2O. Listen. In water molecule, the central atom is oxygen. Listen. And how we draw the bonding structure in water? Listen. Oxygen having 6 electrons, 4, 5, and shared with 2 hydrogen atom. Hydrogen having 2 electrons, 2 hydrogen having 2 electrons, and these three electrons of here hydrogen, and in this way 1, 2, 3, 4 electron pairs are formed. Oxygen atom surrounded by four electron pairs. And these electron pairs are 2 are bond pair and 2 are lone pair. Not these 2 pair does not involve in bonding. There are 2 bond pairs and 2 lone pairs. Yeah. And what we know that if there were 4 electron pairs, then tetrahedral angle, but there is presence of 2 lone pair causes maximum repulsion occurs, and we found that here these lone pair repel each other and bond pair get stressed or pushed away. That is due to repulsion between lone pairs. And due to presence of lone pairs, the actual bond angle decreases less than tetrahedral angle. The actual bond angle decrease than tetrahedral angle. Tetrahedral angle is 109.5 degree and stabilizes at 104.5 degree and giving the shape angular bend, that is V-shaped. It gets bent downward and giving the shape like angular shape to minimize repulsion between here. That angle will be 104.5 degree or nearly around the 104.5 degree. It is called the structure of shape of water molecule. After that we discuss one more shape related to or given by or explained on the basis of VSEPR theory, hydrogen sulfide. H2S. In hydrogen sulfide, the central atom is sulfur, and that sulfur contains two bond pair and two lone pair same as a water molecule. In hydrogen sulfide, the central atom sulfur remains surrounded by four electron pairs. Listen here, four electron pairs are found. There are two bond pairs and two lone pairs, and we know that there is maximum repulsion among the lone pair, and hence the repulsion between or repulsion among lone pair push bond and stabilizes in bent angular form. In bent angular form, it gets stabilizes, giving bond angle (92.5°). In case of water, we found that 104.5 or 7°, and here less bond angle is found, that is more pushing occurs because size of sulfur is here. Here angle of HOH is 104.5°, but HSH is only 92.5 because sulfur has large atomic size, and that will cause limitations of VSEPR theory. VSEPR theory could not explain about the structure of some molecules, like it could not predict the shape of very polar molecules. Like lithium oxide. It explains the structure of H2O, but could not explain about the structure of lithium oxide because it is more polar than that of water. Other is here, it could not explain the actual bond length of molecules. In molecules, it only gives about certain amount of repulsion occurs and bond angle get decreased. But how much get decreased, it could not explain about it. Other, it can't explain the shape of complex compounds formed by transition metals. Transition metal form various type of complex compound, and its shape geometry can't be explained with help of this theory. These limitations are found in here given that VSEPR theory, and due to that reason, to explain more structure of molecules, here we study about other theory like valence bond theory in next video. Thank you.